In our next example, we're looking for the mass in kilograms of a rectangular 24 karat gold bar. So that's a pure gold bar. So essentially we're talking about the element gold. That is 2.00 centimeters wide, 5 centimeters thick, and 45.72 centimeters long. So we write down what they give us. We know we're looking for the mass because it says what is the mass. Now you'll notice that they want it in kilograms, so that's going to be a little bit of a hiccup for when we solve for this. It tells us rectangular, so that's kind of giving us a clue that, hey, this is a certain shape, and maybe since they don't give us the volume, that we have to calculate the volume. One of the things you'll notice is that I neglected to write down my length, width, and height. So I'm going to do that real quick. It really doesn't matter which one you say is the length and which one you say is the width and which one you say is the height, because you're multiplying them all together. However, I'm going to follow what it says, so that's going to make our thickness the third thing, which is our height. So we know from the density formula that mass is density times volume. And if we can get it also from our formula triangle by covering up mass, and we're left with D times V. But since they don't give us the volume, but they give us length, width, and height, so we have to use our volume formula, and we're going to substitute length times width times height for the volume in our density formula. And so that's going to be our modified formula. Density times length times width times height. So then we're going to plug in our numbers. Our density is 19.31 grams per 1 centimeters cubed. So I'm going to put 19.31 grams on top and the centimeters cubed on the bottom. I'm going to split that fractional unit up so that they're not on the same side of my dimensional analysis line. So we're going to plug in our other numbers: 45.72 centimeters, 2.00 centimeters, and 5.00 centimeters. And I know they go on top because, one, my formula says that we're multiplying by them, so that tells me. And also, if we look at our units, in order for centimeters to go away, centimeters has to go on top. So you'll notice that the centimeters cubed on the bottom is centimeters times centimeters times centimeters. And so if you know that, you can just automatically cross off those 3 centimeters. If you're not sure, then you can do it this way. You cross one top centimeter off, that changes the centimeters cubed to centimeters squared. Then you cross another centimeter off the top, that changes the centimeters squared just to centimeters on the bottom. And then you cross the last centimeter off, that's going to finally get rid of centimeters off the bottom. So we're left with grams, but we want our answer in kilograms. So that means we have to go to our conversion table, and we look up, and on the conversion table, specifically the metric side, and we find that 1 kilogram is equal to 1,000 grams. So now we got to figure out, where do I put the kilogram and where do I put the 1,000 grams at? Well, dimensional analysis tells us that the unit tells us where to put the numbers. So since grams are on top already, we want grams to cancel out. So we're going to put the 1,000 grams on the bottom, and we're going to put the 1 kilogram on the top. And that line that I just drew, that vertical line, that just separates your different parts. So we could have put a line between each thing, and that's just to help you keep track of the different steps. So our grams are going to cancel out, and that's going to leave us with kilograms. So when I take 19.31 times 45.72 times 2 times 5 divided by 1,000, I get 8.82853. So that's our calculator answer. So the last step is to figure out how many sig figs it has. So multiplication and division rule, you go with the least number of sig figs. 19.31 has 4 sig figs, 45.72 has 4, 2.00 has 3 because those are trailing zeros and there's a decimal point, and trailing zeros, when there's a decimal point, are significant. 5.00 is going to have 3, and our 1 and our 1,000 here, since that is a conversion factor, those are true by definition. They're going to have an infinite number of sig figs. So our least number of sig figs of these 5, 6 things is 3 sig figs. So that means our answer is going to be good to 3. So we start from the left, 1, 2, 3, and so that means that 2 is going to be our last significant figure. So we look to the right of that 2 and we see what that number is. If it's greater than 5, we round up. If it's less than 5, we round down. If it's exactly 5, we round to make it even. So since the next number after the last sig fig is greater than 5, that 2 is going to round up to a 3, and we end up with 8.53 kilograms. So this problem is almost exactly like the last problem we just did. We're looking for the mass, they give us the substance, and they give us the length, width, and height. So that tells us we can use the length, width, and height to calculate the volume, and we can use the density of the substance to calculate the mass. So we know we're trying to calculate mass because it says what is mass. Record the other stuff that they give us. Then we have to realize that they didn't give us volume, so we have to use one of our volume equations to calculate the volume of the object. So a room is rectangular in shape, so it's length times width times height. And the density we can look up on the density data table. So we look on the density data table under density of gases. Since it doesn't say it's at STP, we have to use the air one that's at Coleman, and that's at room temperature, which is 20 degrees Celsius. So we use that very first entry, and we find that the density of dry air at Coleman, which is 500 meters above sea level, and at 20 degrees Celsius is about 1.167. We know that mass is density times volume, either by algebraically rearranging the mass, the density formula, or by taking our formula triangle and covering up mass, and we get density times volume. They don't give us volume, so instead of writing a V, we're going to write D times length times width times height. And remember, you always have to write a formula for every problem that you do. Once we have our formula figured out, we're going to plug in our numbers. So our density, we're going to put in 1.167 grams, and that's per 1 liter. So we're going to put the liter opposite of it so that we don't have a fraction inside our fraction. And then since we're multiplying by length, we're going to put our length on top, and we're going to put our width on top, and we're going to put our height on top. Now, meters times meters times meters is going to give us cubic meters. But cubic meters and liters are not the same unit, so they don't cancel out. So we have to find the conversion factor between cubic meters and liters in order for those units to go away. So we look on our conversion chart, and we find that there are, for every 1 liter, there is 10 to the minus third cubic meters in it. So we're going to put that in. So since we want liters to go away and we want cubic meters to go away, since liters is on the bottom, we put the 1 liter part on top, and we put the 10 to the minus third part on the bottom. So 10 to the minus third cubic meters. So liters will cancel out. Okay, and since we have meters times meters times meters, that gives us cubic meters on the top. So that's going to cancel all 3 of those meters. And so we're left with units of grams, which is the unit of mass, and that's what we're looking for. So when we take 1.167 times 16 times 9 times 3 divided by 10 raised to the negative third power, we get 504,144 grams, which is our calculator answer. So the next step is to figure out how many sig figs to round it to. So remember, we go with, since we're multiplying and dividing, we go with the least number of sig figs. 1.167 has 4 sig figs, 16.0 has 3, 9.00 has 3, 3.00 has 3. And then our conversion factor, that is true by definition, so it's going to have an infinite number of sig figs. Of those 4 measurements, the least number of sig figs is 3 sig figs, so that means our answer is only good to 3 sig figs. So we start counting from the left, 1, 2, 3. So that means that 4 is going to be our last significant figure. So we're going to round at that 4. So that means we look to the right of the 4 to see what the next number is. So if the next number is greater than 5, then that 4 would round up to a 5. If that number is less than 5, then that 4 is going to round down, which means it stays the same, and you just drop all the other numbers. The next number is a 1, so that tells us, since that's less than 5, that tells us that 4 is going to round down, so it stays the same. But we have to add in placeholder zeros because 504,000 cannot round to 504. Okay, so our answer is about 500,000. Our final answer has to be about 500,000. Okay, you can't change to about 500. That would be completely wrong. That's 3 sig figs because those last zeros are trailing zeros and there's not a decimal point. And remember, captive zeros are always significant as well as non-zero numbers.